Hello, guys. Excuse me. Hello, ladies. Welcome back to Prospect Charter School's Pre-Calculus class. This is going to be a rehash of section 10.2b. A rehash in that we're going to go over it again, and we're going to make sure that we have it down because, yes, this stuff can be difficult, but I think we can figure it out, and I think we can do really well with it. So when last we were looking at summation notation. And summation notation looks something like a sigma from a number starting to an ending point of something. And what we need to know is what each piece means. This portion means start at A. Usually we start at 1 or 0, but there are some cases where you would start somewhere else. Then we have the piece up here, which is the end point, which means that we end at B. The sigma portion of it means add it all up, and the a sub n portion is usually an equation that creates a sequence. Now, whenever we have these, this is what's called a series. Now, what is the difference between a series versus a sequence? It's really easy. A series is a sequence that's added up. So every series has a sequence within it. Now let's look at some of the very special cases. The first very special case is, if you guys remember it, the Baby-Gauss formula. This is when Gauss was told when he was little that he was not allowed to go outside until he had added every number from 1 to 100 together. So in essence, he was asked to find the sum from k equals 1 to 100 of k. Well, they found this one to be really easy. He wrote them twice. He added them together and realized that it was just 101 added over and over again, and he had 100 of them. So the formula that he had was k times k plus 1 all over 2. So, with that in mind, and with your notes, I'm certain you know the other formula that was involved. So one of the tricks that we've learned is this particular formula, which is called the Baby-Gauss formula. Now, the other thing that we needed to get down was the general term of an arithmetic sequence. So let's write that down. General term of an arithmetic sequence. And this is basically how you can find where you are in your terms. And that is a sub n is equal to a sub 1 plus n minus 1 times d. Now, this might look like gibberish to you, so let's go ahead and break it into each piece. A sub n is the value of the nth term. So if we're looking at the first term, this would be the value of the first term. If we're looking at the fifth term, that would be a sub 5, or the value of the fifth term. If it was the 70th term, it would be a sub 70, and it would represent the value of the 70th term. A sub 1 represents the value of the first term. This is also called your starting value. That's where you begin. This D portion over on the right, this represents the common difference. So if you take the difference between any two terms in a series that is arithmetic, it will always be the same number. Like the 49th and the 50th term will always have the same difference as, say, the 500th and the 501st term. And that leaves just this n minus 1 portion, which is just that. It's n minus 1. So if you're looking at the fifth term, you go 5 minus 1. That is how we find each individual term's value. So for an example, let's say that we are given the sequence a sub n is equal to 3, 5, 7, 9, 11, 13, ... Now, if we're looking at this sequence, we need to find out what the general term is, or in other words, which term are we looking at when we go to, say, like the 10th or the 20th place. We want to find out what that value is. To do that, we first have to find out what our a sub 1 is. Our a sub 1 is always our first term. So our first term, being 3, just gets pulled down, and we have 3. Now, the D is the common difference. If I look between any two terms, from 11 to 13, I add 2. From 5 to 7, I add 2. From 3 to 5, I add 2. So in this particular case, my common difference is 2. Now let's say that I'm told to find a sub 21. To do that, I start out with my first term. My first term is 3. And then I add to that the number of terms that I'm going to minus 1. So I'd have 21 minus 1. And I multiply that by my common difference. My common difference is 2. So the 21st term of this sequence would be 3 plus 20 times 2, which gives us, hold on a second, which gives us 3 plus 40, or 43. Now let's move on to the next piece. The next piece is what happens when I add up a weird number of things. So for an example, let's say that I'm told to find the sum from n equals 8 to 19 of 2n plus 1. Well, for this one, what we would have to do let's just call it 2n. So for this one, we have to confirm that it's arithmetic. Yes, it is. Okay. Then we have to figure out how to add them together. Fortunately, we're given a beautiful formula for this. So the sum for the first n terms of a formula, or of a summation, goes like this. Actually, let's put this guy on the back burner for now, and we'll come back to it. So to be able to figure that one out, first we have to find out what the sum from n equals 1 to a is, no matter what sequence that we're given. As long as it's arithmetic, we can figure it out pretty easily. Stop doing that, computer. Be nice. Thank you. That formula would look like n over 2 times the quantity a sub 1 plus a sub n. So what does this mean? Well, let's say that we were told to find the sum from n equals 1 to 5 of 2n. Well, in this particular case, we'd be looking at n being our final value of 5. So this would be 5 over 2 times the quantity, and then we need to find out what my a sub 1 value is. So we plug 1 in to begin with. So 2 times 1 is 2. So my a sub 1 would be 2 plus my a sub n value. Well, to figure the a sub n value, I have to use that previous formula where a sub n was equal to a sub 1 plus n minus 1 times the common difference. In this case, the common difference is going to be 2. So we'd have a sub 1, which we discovered was 2, plus my n, which is 5, minus 1 times my common difference of 2. So it gives me 2 times, or 2 plus 4 times 2, which we all know as 10. So I have plus 10 right there. And then we do the arithmetic. Let's see. 2 plus 10 would give me 12. 12 divided by 2 is 6. 6 times 5 is 30. So if I add up the first 5 terms of this sequence, I should get 30. Now, to double check it, let's go ahead and do it. Because it's only 5 terms, we can figure out 5 terms. So this would be 2 plus 4, 6, 8, 1, 2, 3, 4, and then 10. Adding them together, we get 10, and then 8 and 2 is another 10, and then 4 and 6 is another 10. 10 plus 10 plus 10 is 30. So it checks out. So this is a really neat trick that we can do to figure out the first n terms of a problem. But how does that help us with our original problem? You know, that one that was the sum from n equals 8 to, say, 19 of 2n. Well, by itself it doesn't, but what we can do is use our brains and think about it for a minute. If we know how to go from 1 to 8, then we can probably break this into 2 pieces. We can break it into the first set of terms, which is from 1 to 19. Now, that would give me all the terms, but I need to have the first 7 removed. So then I would be like, okay, well, let's subtract the first 7. Because it starts at 8, so we have to include the 8. So here we want to stop right before we reach the 8th term. So in general, when we're looking at the sum from n equals a to b of a sub n, if it's an arithmetic sequence, we can change that into the sum from n equals 1 to b of a sub n minus the sum from n equals 1 to a minus 1 of a sub n. In other words, we stop one step before our starting point. Doing this allows us to figure out just about anything with arithmetic sequences. It's really awesome. I think it's a pretty cool trick. I would highly recommend it to anyone who reads these or anyone who works with these. Okay. So, at this point, I would like to say that I am way too tired to continue and that I'm going to call it a day. And here's what I would like you to do. I would like you to do some homework. And this homework is very important. So I'm not going to give you stuff that's just willy-nilly, whatever kind of things. I want to give you stuff that's actually meaningful, which means that I'm going to give you word problems. This is going to be section 10.2. Hashtags, being sick is bad, but math is awesome. And I want you to do numbers 63, 65, 70, yes, I know it's an even number, but we'll be going over these in class together, and 71. This will let you understand where these things can be used, and they have so many real-world applications that it's not even funny. This is how some people are able to calculate what their payments on their car will be, given a given interest rate. This is how investments work. This is how banking works. This is how housing mortgages work, is all by using this kind of summation notation. And this is how Mr. O'Neill discovered that his credit card company was cheating him and got $150 back from them because of it. So it does have real life applications, and it allows you to not get cheated by those that would want to cheat you, which is a good thing. Because it's really easy to cheat and steal from the ignorant without them even knowing it. I don't want you to be ignorant. I want you to be knowledgeable. I want you to go forth into this world with your minds open, able to think, able to know when something is wrong. Because that will make your lives much more wonderful. And the last thing that I want is for any of you to have a horrible life. Anyway, that's it for me. Good luck and have fun.